There is another example utilizing multi-domain group layer. It is divided into domain 1 and domain 2, and after defining each domain, input the simulation conditions. So the first thing to do is creating a new project. Click this New Project button. Enter the name of a project file as ex2 and then click OK. So from now on, let's define the structure. At first, I will define domain 1. Drag and drop all used layers to the stack list. Since the domain 2 transparent area requires 2 glass layers, define them below domain 1. So I will just copy and paste it. First of all, let's change all the thickness. And then let's check the refractive indices. For the EML, I will change it as constant. And in the simulation conditions, external bottom is used in this example. Click Light Source DB and please drag and drop the Light Source DB into the external bottom. Also, for the EML, a unit source is used. So, just double-click the source icon. And the dipole orientation is isotropic. So you can see that the dipole orientation is isotropic. And all of the glass layers should be set as incoherent layers. So for the glass layer, I will change it as an incoherent layer. And next, let's make a multi-domain group layer. Select the layers for the emitting area structure. Right-click to convert it to a stacked group layer and name it as emitting. In the same way, select the layers for the transparent area structure. Right-click to convert it to a stacked group layer and name it transparent. Then select two stacked group layers and then set them as a multi-domain group layer. You can change the name or set the ratio of each domain. In this example, the domain ratio is as follows, and the link option should be used. So select each ratio as variable and click the variable tab. Enter each range. And let's check the link option. I already talked about it, but there are some precautions when using this option. The item to be linked is designated with the same name, and the number of variables must be the same. So I will enter letter A for each link option. And the number of variable conditions is the same as 5 each. It makes sense. And lastly, let's set the output condition. For the viewing angle, theta is 0 and phi is also 0 degree. So I will change it. And for the in-plane wave vector condition, I will modify like this. And then set the wavelength condition as 10 nanometer step. I will not use this option in this example. So everything is done. Click Save Project button and then click Run. When the calculation is completed, TechWiz OLED Viewer is opened automatically. Since we checked all results and functions in the previous example 1, for the example 2, just look at the graph result. In this case, it is a multi-domain group layer, so you can select a specific domain, or also you can check the total. Source type shows as a list form because I set 2 types of light source, external bottom and emitter of EML. Click internal, which means emitter, and data is radiance, x-axis is wavelength. For the domain ratio, I will select as variable, and then click plot. In this way, you can check the radiance graph according to the wavelengths for each domain ratio at a glance. So, this is the smallest one. The smaller transparent area, the larger the emitting area. Therefore, it can be seen that the smaller the transparent area, the larger radiance value. So this is the end of how to create and analyze the multi-domain group layer. With some examples, I have finished the explanation about TechWiz OLED. For detailed information on functions of the program, please refer to the manual. Since this training video was produced using May 2022 version, Functions will be added or UI may be slightly changed later on. And if you have some questions about the program, please send us some email. Thank you for watching this video.